Okay guys, so we are doing this question number 10. Okay, this is 10th question. We are doing question number 10 here. Now the question is, okay, we are finding out here del square u upon del x del y, okay, of this function which is x plus x, which is del u del y. Why del u del y? Because we have to prove that del square u upon del x del y. As I have told you, this del y is first differentiate with respect to y, then with respect to x. Now we have to differentiate with respect to x. Before that, del u del y, let me summarize this. It could be, simplified further. Now let me simplify this because this has become lengthy. It could also be the, result into the same value. Okay, the same result can be obtained through this lengthy method. But let me find out this shortcut method. What is shortcut method here? If I, okay, let me resolve this in a short manner. What is the short manner? If I solve it further, del u del y can be taken as x common in the numerator. This is 1 plus x square. Alright. In the denominator there is something common here. In this I see that there is common y square here. This is 1 plus x square plus, if I take y square common from these two, it will be 1 plus x square also. Okay. So in first bracket, in another bracket we have 1 plus x square plus y square, but it is under the square root. This value is under the square root. Alright. Now from this, if I take 1 plus x square common, it's 1 plus x square in the first bracket in the denominator is common here. Let me take that common. Okay, so this lengthy method could also be done without taking common and solving the whole thing. Okay, it has made it very lengthy, but answer will be there. There is some calculus mistakes will be lengthy. Calculus mistake can occur in this case. But if I solve it very simply after simplification of this whole question, it means in the denominator, if I take common here, 1 plus x square is common. 1 plus x square is common here. In another bracket, we are get it 1 plus here y square. So the factors of this equation are 1 plus x square into 1 plus y square. Under the square root, in another factor is 1 plus x square plus y square. Okay. Now we see here this 1 plus x square cancelled out. We are left with only x upon, this is 1 plus y square within another bracket, 1 plus x square under the square root plus y square. Under the square root, 1 plus x square plus y square. So this is the simplest form. Let me differentiate this with respect to x. Okay, because now we have to differentiate with respect to x here. This is del square u upon del y, del x, del y. Now del x means we have to differentiate it with respect to x here now. So let me differentiate it with respect to x. This lengthy method could also be, taken if we have time, but here we are lack of time. So let me solve it hurriedly. Now, if we differentiate, there is no mistake here because we have taken common, we have simplified this function. Whatever simplification can be done is to be done. Otherwise, the question can be lengthy. It may take more time. Okay. Now, let me differentiate this equation. This is value of del u del y. This I have already written here that differentiating first with respect to y first, then with respect to x. So no need of writing. Okay, so therefore, and differentiating it further with respect to x here, this is del x del y. So what we obtain here? Now differentiating this function. Now this is with respect to x we have to differentiate. We are left with x upon under root 1 plus x square plus y square. This value is having including x. This 1 plus y square is constant, considered as constant. If I take it as common, 1 upon 1 plus y square as the common, and if I differentiate this x upon under root 1 plus x square plus y square as a quotient, okay, with the help of quotient method, with respect to x we have to differentiate it. So first denominator as it is, that means 1 plus x square plus y square as it is. Differentiation of x, the numerator, that means 1 into 1. minus sign in between. Now x as it is, numerator as it is, differentiation of denominator, which is under root 1 plus x square, this is into 1.2 power. Now power left is 1 plus x square y square whole power minus half. I'm sorry, this is minus half now, because half minus 1, that means minus half. Power left. Now inside the bracket, inside the square root, we have here 1 plus x square y square, which we have to differentiate with respect to x. This 1 is 0, differentiate with respect to x square is twice x. Differentiation of this whole, and y is 0. Y square, because we are differentiating with respect to x here, divided by 1 plus x square plus y square, square root whole square, that means this cancelled out. This is square root, if it's square, and square root and square cancelled out, because square root means 1.2 power, and square is 2, so 1.2 into 2, that means 2.1 power. Power of this 1 plus x square plus y square is only 1. Okay. Now let me solve it further. This is 1 upon 1 plus y square, which is out of this whole solution. Now let me solve it further. This is under root 1 plus x square plus y square only. This is minus sign. Now this 2 and this 2 cancel out. This is x square, x into x square, divided by under root 1 plus x square plus y square, plus minus half power. That means we can take that into denominator as square root, divided by 1 plus x square plus y square, only 1 power. Now if I take LCM, this under root 1 plus x square plus y square as LCM, that will come here with under root this square root will be cancelled out, because half power plus half power is 1 power, so this square root is cancelled out. Let me write here 1.1 plus y square. Then here we are left with 1 plus x square plus y square only. No power is, half power plus this half power of this square root will be removed. That means 1 power only. Now with minus x square only. Why? Because this minus x square under the denominator we have this under the square root. This is LCM, where it will be 1 into x square, that means x square, divided by, now this under root 1 plus x square will come with this, so 1 power plus half power will be 1 plus x square plus y square, power is half plus 1, okay, that means 1 upon 1 plus y square, within bracket, this out of the bracket, okay, and this x square cancelled out. In the numerator also we are left with 1 plus y square, divided by 1 plus x square plus y square, whole power 3 by 2 now. This is 1 and a half, 3 by 2 power. This 1 from 1 plus y square, 1 plus y square cancel out. So we are left with nothing but the answer. This is 1 plus x square plus y square, whole power 3 by 2. This is the answer we are left with. Okay, so answer we have obtained here. It's the same answer here. 1 plus x square plus y square, whole power 3 by 2. It's clearly solved now. So instead of taking without, okay, simplifying the question may take more time. Okay, answer may be same, but it may take time. Okay, in case of taking common again in the end, but before that we are just simplified, taking x common here. This is 1 plus x square, 1 plus x square cancelled out. After simplifying this, taking factorizing this, so this factorizing 1 plus x square plus y square, 1 plus x square cancelled out, x upon only this 11 time. This is further differentiated. We have obtained the answer here. This is the 10th question which we have solved. Let me take the 11th question and the 12th one, which are the last question of this exercise. And let me take 11th question of the lecture. Now question number 11, let me take. Okay. Now, question number 11 says that this one, if u is equal to, let me write here question number 11, if u is equal to e raised power x, y and z. Alright, then prove that, then show that, to show that This is to show that what we have to show here del q u, okay, del q u from del x del y del z of x is equal to, this is within bracket 1 plus 3x by z plus x square y square z square, okay, into e raised to power x y z. This we have to prove here. This 11th question. Del q u upon del x del y del z equal to 1 plus 3x by z plus x square y square z square. Okay. It means here u is a function of x, y, z. Okay. More than two functions independent variables here. More than two independent variables here. So u is a function of more than three independent variables. X, y, z. Okay. So let me first. This is equation number one. First, before differentiating, let me take logarithm of this. Taking log on both sides, on both sides of 1, we get this is log of u is equal to x by z, whatever the powers are, into log of e. Log of e to the base e, here base is e. We are differentiating, okay, we are taking log here. So all these x, y, z will be independent now. So log e is 1, this is x, y, z. So this is 1 log e, uh, log of e to the base e, same base, log of 10 to the base 10, 1. Log of a, log of a to the base a is 1 always. So whenever the base is same and we are taking log of a number, okay, this has the same base is equal to 1 always. Log of e to the base e is equal to 1. This we know. This is 1 here. So only x by z log u is equal to, this is x by z. Let me take this is second equation. So let me differentiate it with respect to z, with respect to u, with respect to y, because we have to differentiate this whole with respect to all the three steps. So first let me take single differentiation. Differentiating is second. Let me write here. Differentiating second with respect to x, y, and z respectively. That means this is partial differentiation. When we are differentiating with respect to x, then y and z constant. With respect to y, then x and z constant. And with respect to z, we are differentiating, then x and y taken as constant. This is obvious because we are doing partial differentiation. Simple question. So differentiating first, for the second with respect to x first. This is 1 upon u. Differential log of u is 1 upon u. But u is a function of x, so du upon del u upon del x is equal to here. Here we have as differentiation of x only 1, y z constant, so it is nothing but y z only. This implies that del u upon del z del x equal to u into y z. This is third equation. Similarly, let me write here. Similarly, if we differentiate with respect to y, then y will be differentiated, that will be x into z, u into xz, that will be here. Del u, similarly del u del y will be u into xz. Simple logic here. Differentiating this equation, this one, sorry, this equation, log u is 1 upon u del u upon del y equal to xz, because y will be 1. Xz constant in case of differentiating with respect to y. This is del u del y equal to cross multiplication, u will come here, so this is u into xz. Similarly, and del u del z equal to u into x by z will be as one differentiation. Difference of z will be 1 here, x by will be constant here, u into x by. This is we take equation. These three will be helpful. Let me now solve the third equation, because what, sorry, this one, fifth one, because first is del z we have to take. First is z, I mean with respect to z, then y with respect to x, then finally. So we have taken del u del z. This is del u del z. differentiating fifth one with respect to first y, with respect to with respect to y, then with respect to with respect to x, finally with respect to x. That will be respectively. Means first with respect to y, because we have to find out del square u del y del z. So this will be del square u del y del z. What is the differentiation of u x y? Now we are differentiating with respect to y. X is constant. Let me take x constant out. Now u into y will be differentiated with a function of y. Okay, so with respect to y, that means first let me take u as it is. Y is 1. Differentiation of y with respect to y is 1 plus sign. Now y as it is, sorry, x we have taken already common. So then u will be del u del y. Why? Because we are differentiating with respect to y here. So u is del u del y as it is, x here. What we have obtained here, ux multiplying by x will be y x into y del u del y. So finally this will be ux plus xy into what is value of del u del y. Del u del y from fourth one is u x z. This is u into x into z. Okay. This is from fourth. From fourth we have obtained this value. Now let me write it again. Ux plus u, if I take common on out, this will be xy into xz. That means x square into yz only. This is the first equation. Or let me write it as u taken common will be x plus x square into yz. This is, let me write it as sixth equation. So let me write it as sixth equation here. Sixth equation is here. This is del square u upon del y del z. That is equal to u into within bracket x plus x square y into z. This is the sixth equation. Okay, now differentiating sixth. Now with respect to x, because final value will be here. Differentiating sixth now. Differentiating sixth with respect to x. So we get that I've already written. Then with respect to x. So now we are different with respect to x here. So what will be that value? Let me write here. This is del q u upon del x. We are different with respect to x now. Del x, del y into del z already there. It will be u into this value. Because we are different with respect to x. U is a function of x. Let me write here u as it is, first function as it is, multiplication log this u into this in the bracket. So differential of x will be 1 plus x square will be twice x into yz constant. Okay, this is first function. First differentiation, first function as it is, second differentiation. Now second function as it is. That means x plus x square yz as it is. U is del u del x. Okay. So let me now substitute the value of del u del x from third one. Del u del x is this value. Substituting the value of del u del x, which is here. This is u within bracket. This is 1 plus twice x by z. Okay. If I take u common, still it is there. Plus this is x plus x square y into z. Now del u del x is u by z. U into yz. This is from third one. Let me write here from third. From third, this value of del u del x I have substituted, which is u into yz, u into yz. I multiply this inside. It is nothing but u here. This is u, okay, plus u into twice. Let me write it as it is. 1 plus twice x by z. Okay, let me write it smaller bracket, no problem. Plus here we have u common out of this bracket. It will be by z means x by z. First step is x by z. Plus here by z multiplied with this by z, it will be x square y square into z square. Now u is throughout common. If I take u common throughout, that will be 1 plus 2x by z, this one, plus x by z, plus x square, plus, sorry, x square y square z square, y square into z square within bracket. So we have obtained, let me write it here. So finally, what we have obtained here, this is u into within bracket 1 plus 3x by z, twice x by z plus x by z, that is 3x by z, plus x square y square into z square. This is finally. Now value of u from first equation. What is value of u here? Let me substitute. U is e x by z. This is nothing but e x by z within bracket 1 plus 3x by z plus x square y square into z square, which is either multiply in the end ex by z or put it before. That not a matter of discussion, or we can write it here. Or this is 1 plus 3x by z plus x square y square z square into e raised power x by z. Del of u. This is the answer here. So del q u upon del x del y del z equal to this value, which is correct. Okay, so it is proved. And so this is the 11th question we have proved here. Okay, the C del is obtained. Now let me take the 12th question, which is the last one. What the last question says. Now question number 12. What does it say? Marks. Okay. Okay, so 12th question is, let me check what is 12th question says. Now question number 12 here, it says if u is equal to f, this is y plus ax, okay, plus 5 into y minus ax, alright. Then to show that, what we have to show, and show that del square u upon del x square minus a square del square u upon del y square. This is del y square. Okay. Del y square it must be, so del square u upon del y square, it is del y square, sorry. Okay. This we have to do. And let me take this as the first equation. Equation number, this we have to prove or solve. Now let me differentiate. Differentiating first with respect to x and y respectively, and as I always say, that when we differentiate with respect to x, then y will be kept as constant, and with respect to y after that, then x will be considered as constant. Okay. First del u, del x, let me find out. It will be f dash first function y plus ax. Okay. F dash means this first differentiation with respect to x, but here in the bracket we have y plus ax. Y plus ax will be differentiated again function of the function method. Y is 0 because we are different with respect to x. With respect to x, it means this is okay. Here it will be a only because ax is differentiated again. That means a into x is 1. Okay, plus, I'm sorry, let me write here, plus phi dash, the phi dash differentiation of phi into y minus ax into minus a, because y minus ax again differentiated by function method. Y is 0, minus ax is minus a, x is 1. Okay, so let me write it in a proper manner. This is a into f dash y plus ax. This is minus sign a into phi dash y minus ax. This is, let me take second equation. Okay, now, and del u upon del y, del u del y, let me, we are using with respect to y. Okay, so this is nothing but f dash y plus ax. If y is differential again, y is 1 into 1 is nothing, the same value. But ax, we are not using, and ax is 0 after the function of the function method. The first is f dash into y plus ax. Y plus ax if it's differentiated again, and y is 1, ax is 0. Only 1 multiply, same thing. No change. This is phi dash. Here also this is y minus ax. Y minus ax again different because it is single 1, so no change. The same value will be here. This is the third equation. Differentiating second with respect to y, so with respect to x, because del square u upon del square u property. To differentiate, let me write here. Differentiating second with respect to x again, and third with respect to y again, we get here del square u upon del x square different with respect to x again. Here it will be a into f double dash y plus ax into a again multiply, because y plus ax again differentiated with respect to x. A will be here minus sign a, okay, into phi double dash into y minus ax into minus a multiplied. It will be nothing but a square into f double dash y plus ax. This is minus minus plus, is plus a square into phi double dash y minus ax. This is your fourth equation. Let me take. So if I take, okay, this is del square u upon del x square, and differentiating third with respect to y again, it will be and del square u upon del y square is equal to here. Here y is again differential with u1. It's nothing but f double dash y plus ax plus phi double dash into y minus ax. Okay, what we have to prove? Minus a into a del square y del square u upon del y square. So if I multiply this whole by minus a square, okay, that means this implies that minus a square into del square u upon del y square will be equal to, this is minus a, if I take common throughout this, this is f double dash y plus ax. It is plus phi double dash into y minus ax. Okay, this is 4. So minus a square into this. And here we have taken, here a square, if I take common, in this one, this will be a square within brackets phi double dash into y plus ax plus a, so a square I take common. And this is phi double dash into y minus ax, value of del square a u upon del x square. This is a square out of bracket. Here it is minus a square. This whole value will be cancelled out. So we see here. So from, let me write it what. This is fifth one. This is fifth one, last one. And this is value minus a square into this del square u upon del y square equal to. We have to multiply this whole with minus a square. So we see here that del square u upon del x square minus a square into del square u upon del y square is equal to this whole value, that is a square in bracket f double dash a y plus ax, okay, plus phi double dash y minus ax. Okay, this value minus sign a square, the same thing, f double dash y plus ax plus phi double dash y minus ax. So this we see is with plus sign, a square, this is with minus sign. This whole value will be 0. Hence it is proved that this is equal minus a equal to 0. This must be equal to 0. Then prove that, show that del square u upon del x square minus a square del square u upon del y square is 0, or this whole value is equal to this, or you could say that del square u upon del x square is equal to minus a square into del square u upon del y square is equal to 0 either, or this equal to this. This I think 0 was removed from there by mistake, was not written by mistake. Okay, but this is like this. So we see here that these two values are equal, or this is equal to 0 here. You have to prove that either this is equal to minus a, this is equal to minus a square into this, or this is equal to 0. This we have proved this is equal to 0. So hence the 12th question is also over. Okay, now I have to finish this lecture now. And for the next exercise, which I have taken here, some more questions based on the same topic, partial differentiation. Then we will discuss about some special kinds of partial differentiation and what are the forms they are. Okay, there are one or more lectures based upon this. Okay, maybe 3 lectures based upon this. So let me decide, and then I'll come with more questions based on the same lecture, same topic, partial differentiation. Partial differentiation is a very important topic. Up to this, whatever questions I have taken, there were some one or two mistakes, but I just picked up that for you to, putting minus and plus sign, that was a mistake only. Otherwise, I completed the whole exercise, whatever is required here. Please go on with this exercise and taking every question seriously and do it first on yourself, and after that see what is the process of differentiation. That can highlight your knowledge. Okay, so this is what we have done here. Okay, then see you in the next lecture. That will I'll take some more questions which are based on this partial differentiation, and very important question in partial differentiation which I have already declared that what is the rule. First we have to differentiate any question, whatever is required with respect to x or whatever independent variable first. Then other variables, independent variables, are taken as constant. Whenever we are differentiating, this is just a general differentiation. In case of differentiations, general differentiation, we were keeping constants, numbers with multiplication. If they were separated with plus sign, minus sign, then they were 0. Same way, here we have to consider the independent variables as